Yeah, so this is Dorna. It's a robotic arm that basically you see right now. It can handle up to 1.5 kilo in payload. And right now, this setup we mounted it on a rail, and everything controls by this controller, what we call robot controller. It comes with multiple I/Os here, and you can also connect different accessories to the robot, control different motors, stuff like those. And the application for these robots, actually we offer it to many industrial users, but at the same time we get a lot of interest from academia and education, especially when they want to teach robotics, AI, vision, and also automation to students. So the robot itself, the mechanic of the robot is basically what we call a 5-axis robot. So it can basically move in a space and handle, like, manipulate objects, different things. So here we also have the software. It's a web-based software. It's a Python-based software, so it comes with a Python API. It's really like people use it in the education and in basically academia. Mainly use it to teach basically coding and programming to students. So basically the web platform is comes with different. Let me actually refresh this page. So the way you access to the robot, you just connect the robot either to your computer or connect it to a router and access it through its IP address. Once you access it, you see the live view of the robot, and then there are many different ways to basically interact with the robot. One is to just basically hand train the robot, move it around in a space and record your positions and let it run. Other ways are to just send commands, create basically it's like a simulation mode where you can design your motions in a offline mode, and then later when you're happy with it, run it inside the robot. Other way is basically to just use Python to use the Python API. You can basically natively write Python inside the robot and let the robot run it for you. Another approach is to use what we call the Blockly. Blockly is a very basically intuitive way of programming. It's like especially for those who are not very familiar with like a Python syntax or other programming syntax, just a drag and drop way of programming. And you have full control. It's the same way as Python, but it just doesn't require you to know that much of programming syntax. You also have like a Jupyter platform, Jupyter notebook platform, if you guys are familiar with Jupyter. And the robot also comes with like its own API. So basically you can run and host and send commands from your own computer and connect it to the other different basically devices like cameras, if you have sensors, if you have other basically computers or other robots. So I can basically show you like turn the robot on and show you some. So the robot has like 5 axes. So I'm just jogging the joints here. So there are 5 joints you can move. You can move in like a joint space or Cartesian space. You have control over velocity, acceleration, jerk, everything. Let me also explain a little bit also about the different accessories you can connect to the robot. So right now we have the rail. The robot is connected to the rail. You have like air tube ports here on the robot, so you can connect, like if you have like grippers, like a suction grippers, you want to grab something, or different type of grippers. Or if you have a motorized grippers, you can also connect it to the ports here on this side. So, and the robot is also comes with 3 additional axes. You can basically control other motors with the robot. Right now we have one for the rail. here I just wrote a simple, basically, code, so I'm just going to run it to just, so the way we, for example, designed this demo is to just, robot goes down. I have to turn on the compressor.
Yeah, but compressor is not turned on.
I was wondering what that compressor is. Now section of gate.
No, it takes 3 seconds. Turn it on.
Excuse me.
Yes.
Since we just need 1 minute video, so let's do the last part. The last part, this is.
He can edit it.
He
He can
can
edit it and take it out.
for
He can
us,
edit
the
it,
last
yeah.
one, yeah. So last one, that version, yeah, we probably need.
Yeah. So basically, you have full control. I mean, we let it run in a very low speed, but you can run it at a higher speed. You can basically do different motions, different type of, like, depends on your basically, yeah, whatever you require for your application. But everything is like whatever I wrote here is like was through a Python. So it was just a logic, come here, go down, turn on the I/O. So it's a very good way of like teaching programming actually to like students to see how basically they can interact with different modules, different items, run something in a loop, or wait for something. For example, have conditions. Or if you connect like a camera, you can have a very advanced like a computer vision. For example, right now the way I program this is to just come over this position and go down. But if you have a camera, you can guide the robot basically. Let's say command the robot to look for, let's say, a green circle, and then you don't have to hard code the position of these chips. Just put them anywhere.
So it has sensors.
Exactly. Or even sensors. So you can get very advanced with these robots. And it's basically, that's why we see a lot of people with different backgrounds from like high school to even like advanced like machine learning or computer vision departments getting like using this robot for their application. Yeah. So
The other
Is
thing
there a newer version of this robot?
yeah. So this is the 2S. The newer version comes fully covered with 6-axis. So with 6-axis, you get more basically range of motion compared to this. Another thing I want to say is about their basically physical aspect is their weight. So these robots are very lightweight compared to what you see in the market. So you can easily mount them on a table or move them around without needing to design like a very heavy fixture or anything like that. So it's easy to transport. They're also very compact compared to their reach. So that's like an advantage for places like schools where they want to move the robots. They don't want to have very like a heavy structure.
The other thing is that this is what they call it cobots, which are collaborative robots. So they're designed to be safe around humans. So basically, if the robot hits into an object, let's say human hand, it's going to detect the collision and automatically stop the motion. And then you can basically continue the program after you clear the alarm. So it's also safe. That's another aspect. But yeah, I mean.
It comes with different grippers, so this is just the box.
So right now we offer these 3 types of grippers. So this is what they call it soft gripper. So it has very soft texture. They usually use it in industry to grab like delicate material, like food material,
Chocolate.
or chocolate.
Fruit.
But the way it works is exactly like the suction cup. So you just connect it to the same adapter and control it with the same basically command. So it comes in 2 and 3 fingers. Right now we have 3 fingers here, but we have also this size for it. Let's see. Can you? Yeah. And then this is also called pneumatic gripper. These are like heavy duty metal 2-finger grippers. We also have 4-finger type. But basically in industry they get these grippers and then they design the jaws or the fingers based on the application that they have, what type of material they want to pick. So they also work with the same basically compressor, but they have 2 inputs, 2 input ports, but it's basically the same concept. So with this robot, we are also releasing the vision with this robot. We have a 3D vision application. Basically, it lets you to see the objects in the 2D space, and also it has a third dimension where you can know how far away from the camera the object is. So it lets you actually navigate in 3D space. So yeah, these are different accessories that come with the robot. So as Jose mentioned, this is the rail that we have. So basically rail has 1 motor. You can have up to 3 additional motors connected to the same controller box and work with the robot. So
3 additional motors
on one robot.
And what would those motors, you say go back, forth?
Whatever, yeah, so basically any type of actuation or motion that you want. So for example, here we connect 1 motor to a rail. You can have another one connected to let's say rotating table or a
Conveyor
pump or whatever, yeah.
Oh, you said, oh, what?
Conveyor belt.
Conveyor belt, yeah, yeah.
Okay.
So most of our customers are basically either using it for assembly lines, for doing like light work in assembly lines in factories. We have a lot of customers using it for testing applications. They pick up something, they do it on a scale or on a like a inspection section and do some testing. We have a lot of people from film industry, so they put a camera on the robot and start, because the motion of this robot are very smooth.
Yeah.
So it can generate very smooth, which is good for film and videography.
In lab automation as well.
Yeah, in lab automation, people use it to move around like lab material, vials, plates,
Microplates.
stuff like that.
So what programming language does it use?
So basically, the main programming is in Python. We have different interfaces. There's a Blockly option. So Blockly is a language where you actually drag and drop different blocks of code and create a program without writing any line of code.
Okay.
And then the robot also has a native scripting language, which you send the commands directly to the controller without using any programming language. But the Python is already hosted on the controller itself. So you don't need to install any basically library on your own computer.
So the drag and drop is the only way that you can code, or you can actually write your own code?
You can write your own
Okay,
code
do
too
that.
in Python, yeah.
It's
Yeah,
pretty
you have that
simple,
option
so
too.
I think that is right.
We have a Python API. That's the way most people use the robot in industrial settings.
Correct, if you want to teach a programming language,
Mhm.
drag and drop might not be.
That's the best, yeah.
And that's immediate feedback, right? So you can write the language, write it, have it do something, and then verify that it works.
Yeah.
right away.
Yeah.
Actually, I don't know if you can see my screen, but that's how Blockly works. So
Look it up.
on the left you have the blocks, and on the right you see the interpretation in Python. So whatever you make here in the left, whatever you
You see the code. so
yeah,
it's
yes.
the
So
corresponding.
yeah, exactly. So that's a very good way of actually them getting feedbacks of what they made, basically.
Right.
Yeah.
You can actually move your robot arm, move direction
Yes,
that you want.
some
And then you can write
aspects
the
of
code
the
for you.
Yeah,
program,
and,
you
yeah,
can,
and then
So
like a
reverse
motion, you
yeah,
can
and then
actually
reverse
simulate
engineer, you
it
can do that as
before
well.
running
So it will
on
generate
actual
the code
robot.
for
That's
you.
very cool.
Yeah.
Can students access this from outside of lab hours, like the simulator?
They can actually, so basically the robot runs on the network that we connect the controller to. So if it's like a local network, they can, whoever is on the network can access to the
So like with this
program.
site being hosted by the controller, is that how it works?
We have also an online version
Oh,
of the
wow.
program. They can just type in lab.dorna.ai.
So they could
They
set
can-
homework
Yeah.
to program the robot.
They can do offline programming there, and then once they're happy, let's say, they can then deploy it on the actual robot.
Yeah.
But they need the robot basically to see the.
Yes.
But the offline version, they don't need the robot. They can just design their motions, their path. Yeah.
That's very cool.
So there are two different ways.
Yeah.
Hopefully we can just come up with a Python programming class that, requires, or robotic arm like one with Python. So it would be easier for students to kind of see the application, what they do, what program they do. It's really can control it. Because the automation and AI and, robotic is the future of computer science. So that's
more
a
interesting,
pretty,
right,
so it
for
makes it
student.
more interesting and they
Right.
see like the use of all the programming and
When they modify the problem,
yeah.
they see the movie.
They see the
So,
right.
yeah, this can.
It is,
basically-
we just came today to assemble, we had them, we actually can take off everything, it's easy enough to disassemble, we store it in our cabinets because we don't want it to be sitting here. Student can come, this is our computer lab. So it's easy enough to disassemble, take, assemble it back again, right?
Yes.
Yeah.
What's the cost of this?
This specific model is 6,000. 5,900. We have another model. It's less industrial model. It's 3,000. But I mean, this one has a lot of features that are basically for industrial applications.
Compared to what we saw when we had the grant to purchase this, and we saw other robotic arms, this was one of the best. Because they go around like 15K, something like not even close to what you see there, it's very, it was not even industrial or real stuff, right? And it didn't, I don't remember, did it come with the curriculum at all? I don't remember, right, yeah. We went to together, we went together.
Visited several.
Yeah, visited a couple of sites.
So this is a part of called Industry 4.0 grant project. So the grant allows us to purchase this.
A lot of the schools didn't know about it, but Anna is always smart enough to go and figure things out for the grant, yeah. So we were lucky to be able to get the money and use it for this purpose. But, if you're in school or you guys are interested, you just have to contact our consultants, Hassan and Hussein and Hassan.
I don't know.
Yeah,
Direct
direct.
question, but does the company already have some pre-programmed resources? Like, let's say you use it and then you just modify it?
Oh yeah. We have a library of examples, different type of applications, and it's already installed on the controller. So you just go open an example and just make some modification. Yeah.
And also a very descriptive, like a user manual. So, like how to, for example, wire different things, how to set it up, stuff like those videos. Yeah.
We have a YouTube channel with, which is a very good resource to start with. We have a very detailed instruction, and we are also working on the curriculum for colleges to basically.
Dorna, does that stand for anything?
The urna is a bird in Persian.
Oh.
So basically, in English they call it crane bird.
Mhm.
So, I mean, there's a lot of similarity in how it looks like and a robotic
And how it
arm.
moves.
Yeah.
Okay. Do you have any companies in the local area that use these robots?
Yeah,
Oh,
yeah.
wow.
Yeah, in California there are a lot of them. In terms of schools, I think we have it in Long Beach, Cal State Long Beach. We have it.
What about
in
Cal State LA?
Cal State LA.
And I
Dr.
think East
Ishram.
LA, East LA has your, I saw it last week. They
East
have-
LA has one unit for test, but they ordered like.
The older, I think they have the two,
That's
they
the
have
older
the
one.
two, right? I saw
Yeah.
it, yeah,
And
I
they
saw it in the,
order-
in the.
We
Yeah.
have in
lab.
Caltech.
Like if we were to adopt or create a program at our school, it would probably be a CTE program. So it would be great to be able to say, this robot is used in local companies, things like that. So there could potentially be, a channel for entry-level jobs or
That
something
makes
like
sense.
Oh yeah, yeah. We can actually connect you to a number of companies that are using in California.
What's the job title, if a student want to apply the job, this kind of, it's called?
Automation engineer,
Okay, automation technician maybe, yeah.
automation technician as well,
or
yeah.
Automation engineer, yeah.
But it's a tool for people to start automating like factory work, labs, stuff like that.
Good. I think that's what, yeah, we can market our engineering students.
yeah.
For this.
Exactly.
Yeah, anything digital, I think a lot of students, especially the younger ones, really
Oh,
They're
they
gonna like
would
it.
love this.
like it, yeah.
Yeah.
And you can, with this, we purchase 3D printer as well, so they can actually
We can bundle it.
bundle it right there, if you are interested, but, we didn't have one, right? We purchased it because the student can actually model their own gripper or, objects that they want to pick up, so it goes together. Exactly especially for that engineering general 101 class that I was telling you, for projects. I told them that, we have 3D printer, we have robotic arm, you guys are planning to do any project and you wanna be using this equipment for your project, you can come to school and we can, help you with that. So, yeah, that's it.